1/3 x squared what? Equals, there we go. All right, so we're going to side map because I only see x in there one time. Yes? All right, subtract 14 minus 14. I get 1/3 x squared equals 12. How do I get rid of a fraction? Multiply by the reciprocal. What's the reciprocal of 1/3? 3. So I'm going to multiply both sides by 3. This is gone. I get x squared equals. Now what? Yes, yes. Reciprocal is always the flip. Reciprocal means flip it over. So 3/1 is just 3. Okay, you're half right. Plus or minus 6. There you go. Yeah. What else? 57. Make sure you take it off because you're solving for x. That. All right, what do I do first? Anybody? Somebody. Add 4. I have 3x squared equals 144. What now? Divide by 3. 3 goes into 144. 48. When I take the square root, 48 is not a perfect square, right? So I need to break it down. What's the biggest? Charlie Ray, what do you think the biggest perfect square is that goes into 48? 16 or what? There you go. 16 and 30. So the solution would be plus or minus 4 root 3. What else? 1/4. Tell me what I do first. Add 7. 1/4 x squared equals 32. Multiply by 4. That's exactly right. X squared equals 128. Square root. What comes out of 128? Biggest perfect square out of 128. 64 and 2. If this is 64 and 2, that means I am 8 times the square root of 2. Yes. Yeah. What else? Anything else? Yes. Yes, please. All right. First things first, add the 3, right? Plus 3 would give me 8x squared equals 600. Divide by 8. X squared equals square root. What's the biggest perfect square I can take out of 75? 25. It leaves me with 3. So I get plus or minus. This would be 25 and 3, which would be 5 root 3. Plus or minus is fine. While I'm right here, let me just say this. Don't ever do this. This is not the same as this. This looks like you're adding square root of 3 instead of multiplying. So be very careful. So don't ever do that. Anything else? Once. Twice.
Oh.
Yeah. I'm listening. Yes, divide by it or multiply by the reciprocal, but you have to do one of the two. So if you had like if I wanted to find the square root of 16, well, the square root of 16 is just 4. But because 4 is a perfect square, I wouldn't just do it again and say that, oh, well, that equals 2. I stop once I take the square root. Like that. So if it was 32. Right, so now this would be 4 and 2. Anything else about any radicals? Ready to switch gears? No. No. Why would you do 16 to 4? You sure? Right, you wouldn't keep going. You don't. Once you do a square root one time, you stop. You don't keep doing it. What else? All right, let's talk about imaginary numbers. What? Who? When? I'm out. That's a lie. I'm pretty sure to be bilingual, you have to be able to speak fluidly the other language and understand it. Just because you say you can say hola and una doesn't mean you can speak Spanish. Yeah. It couldn't happen with radicals. Tell me what it was. You couldn't have a radical in the denominator. Way to go. Couldn't have a radical in the denominator. Now we're going to talk about one more thing that can't happen. Well, it couldn't happen before. Now it can. Any guesses? No. We mentioned it yesterday, but we didn't go into detail with it. What kind of number could I not have under here? Because it just wouldn't make sense. A negative. Negative. Why though? Why, Logan? Tell us why we couldn't have a negative under that radical. You're exactly right. You're exactly right. So if this is negative under here, by definition, I need two things that multiply together to give me what's under here. And the only way to get a negative number when you multiply two things together is if one's positive and one's negative, right? Right. If they're the same sign, you're going to get a positive. Positive, 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 negative, negative, positive, right? So we can't have a negative under the radical until today. Yay, be excited, y'all. Yay. So now we're going to say, this is going to start out easy, but stay with me, okay? What are you typing? We're going to say that the square root of -1, we are going to be representing with a lowercase I. It's always I. I is an imaginary number, okay? We can't do it. It's not a real number in the real number system. What are you doing? Chemistry? I know, I see that. Hurry up. I'm going to wait. You think what? All right, everybody ready? Okay. We're going to let I represent the square root of -1. So now anytime we see a negative under a radical, all we are going to do is drop the negative and replace it with an I. Because remember that property, we could say this is the same thing as this. right? And the square root of -1 is I, so what we're going to do is we're going to say I times the square root of 7. Really, really easy concept. Drop the negative, throw an I in there, and you fix the problem of having a negative under the radical. Okay, we're going to do a lot more with it than that, but literally that's what I means. Okay, that's the definition of I. All right, stay with me. Plus or minuses still apply because it's still a radical. What would that equal? All right, so it's going to be I times the square root of 36, right? I've got a plus or minus out front, but now 36 is a perfect square. So here's where I have to get into kind of pretty math a little bit as to where my variables come. Variables always precede or come before a radical, but if there's no radical, they come after the number, like 5x, 6x, whatever you have. So this would be plus or minus 6i. Does that make sense? To make dollars? Okay, y'all really. It makes a lot of sense. It adds up to $1. All right, smarty pants. Simplify that radical. Everybody's great. All right, what'd you get? That's right. A can be broke down. First thing I'm going to do is pull this I out, right? Because I can't have a negative. That's going to be my first step every time. Pull that I out, and then I can break 8 down, 4 and 2. So I've got this I that sits out front. Now I've got the square root of 4 and the square root of 2. Well, what's the square root of 4? 2. So remember, variables come behind numbers that aren't under the radical, but in front of radicals, so I put it here. Then I do square root of 2, but where should I put the plus or minus? In the very front. Don't squeeze it between anything because that's going to imply addition or subtraction. So it always goes in front of everything. All the same properties still apply. Simplify. Somebody, anybody, everybody's free. Parker was singing it this morning. Kenzie, are there squirrels in your pants? There are all these little calculator buttons, just a. We'll try to go easy on you today and let you do your homework in class for sure, since it's Friday. Ain't nobody want to do math on the weekend. Why are you trying to get a square root up there? What's not that square? But you can try. Nope, just one of them. All right, anybody get the biggest one? 36 and what? 7. So I got I, 36, 7, so I get plus or minus. Does anybody need more of these, or is everybody okay? Speak up, don't be scared. Okay. So we always, when we talk about variables, it's always going to follow any whole number this way or any number, whatever it is, but it's going to be in front of a radical. So that's just pretty math. All right, you got 9 and 28. So here's what happens. This is 3 and this is 28, right? But 28 can be broken down one more time. What's the perfect square you can divide 28 by? 4 and 7. So I'd have 4, I'd have 7. This 3 is still here. Well, the square root of 4 is 2. So this becomes 2. And what's 3 times 2? 6. You come back to the same thing. It's just an extra step because you just didn't pick the biggest one. But that's okay. It's all right. Other questions? All right, I'm fixing to make you think. You ready? I'm done thoughting. All right, what did I tell you I was? Yeah. What'd you say I is? No, I is not -1. Square root of -1, right? What do you think that would be? Oh no, square root of -1 squared. Which is? I hear 1.
1. What if you just multiply those two together? That would make -1 times -1 is positive 1.
Agree, disagree. I'm fixing to show you. What do you know about squares and square roots? They cancel each other out. What's I squared equal? -1. Right? Remember what we talked about yesterday with opposite operations? This and this cancel each other out and leave you with what's under there. So it's just -1. So let me ask you this. If I squared is -1, what might this equal? No, your haircut looks nice. You're welcome. What you got? Finish. Keep going. Hank says 6. Ooh. Don't do that again, Hank. I'm just kidding. Yeah. I agree, but I say it's not completely done. To do something else.
I got -6 because if I squared equals -1, 6 times.
I agree. If I squared is -1, we just said that, then 6i squared would be 6 times -1, which is -6. Oh. Don't go too far from this because we're going to come back to it in just a second. What about I'm sorry. Don't blurt it out when you get it. you'll be doing a little more complicated. I'm just
I know.
easing you into it. But yeah, you could see that. All right. What y'all get? Charlie? Yes. Because this is negative 16i squared, and I squared is negative 1. So it does this. So essentially, tell me what I squared does to a number. Or that you're exactly right. So I think you're all getting to the right thing. You're just saying it different ways. I squared changes the sign of a number. All right. I is the square root of negative 1. I squared is negative 1. What do you think I to the third is?
Positive on the right. Because the negative is a negative. No, it's still negative, right? Negative 2. What? Negative, negative, positive, negative, negative 1.
With the negative.
Right? So depending on what situation we're in, we might have to use one of these two, but generally it's a negative I, and that's what we use. All right, it's going to be a little confusing at first. Stay with me. Take it out one more time. Negative, negative I. You think it's positive I. Anybody else think it's something?
It's a fraction.
A fraction? Somebody, I think, just said it. Wouldn't it be what? 1. Positive 1. Good job. Be confident. You got this. It's positive 1. You got negative 1 times negative 1. It's really I to the fourth is I squared squared, right? Okay. What about I to the fifth? Oh my gosh. Make it stop. Nope. Close. Say that again. Which is? It would.
Wait.
Go another time.
I could be a bank account.
But look what's happening. I'm trying to get you to a point. What's happening here?
It keeps doing the same thing.
You're exactly right. It starts repeating the pattern, right? So I just need not even the first 5. Well, one more than that. The first 4. There you go. So if I know the first, these are what we call iterations. You don't have to know that word, but somebody asked you what you learned in math today. I learned the iterations of I, and it makes you sound really smart, right? Okay, so iterations are just, after a certain number of times, it starts to repeat itself. So now let's think about this for just a minute. Knowing what we know. If I can just remember I squared, I to the third, and I to the fourth, could I figure out any iteration of I? Possibly. How might I be able to do that? In other words, what if I asked you, what is I to the 17th power? Watch what happens. It's not as hard as it looks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is I to the 17th power? Now let's figure out a way we could do this a little bit easier than having to actually count. Because what if I had I to the 77, somebody said. I don't want to count 77 times, right? And then what does that tell me? So you say divide it by 4. You're exactly right. That's exactly right. 4 goes into 77 how many times? 1, right? That leaves 37, 9, remainder of 1. Well, write this somewhere because this is, yeah, write it down. This is remainder 1, remainder 2, remainder 3, and no remainder at all. So the remainder here is 1, so that means that this equals I. Divide by 4. So we divide the exponent. So 0.25 would be 1/4. Right. So if you divide it out, this would be 0.25, 0.5, 0.75, and 0.0. Bruh. What the
Chad, you don't need to be multitasking. Bruh, I'm multitasking.
I tell you what, you tell me the answer to this and I'll leave you alone. Okay? I mean, I probably just told a story because I'll probably still, but. What is 5? Oh, you can't see that color too well. Can you? What is 5? You can. What is 5I to the 129th power? This one's for Hank. This one's for Hank. But everybody go home.
Alright.
All right.
Okay. So it's 0, right?
What?
It's 0. Wait, no.
I think I have it.
Do you think you have it?
It's negative 5. Isn't it?
What is I to the 129th power? So what is 129 divided by 4? Did I do a 1 again? I'm literally making these up off the top of my head, I promise. Your remainder is 1 when you divide by 4, which means I to the 1/29 is just I, so it's just 5I. Right. I am. I'm trying real hard. Okay.
So which one are we looking at when we find like our remainder or the decimal or whatever? Are we making it like that high or like that's equal part?
Well, okay, so for just I, you always just use I, so don't worry about the square root of negative 1. If it's a remainder of 2, you want to change it to negative 1. Maybe I should write that. Remainder 1, we want to, which is 0.25 if you divide, you want to replace it with just I. If you have a remainder of 2, which is 0.5 when you divide, you want to change it to negative 1. If you have a remainder of 3, which is 0.75, you want to change it to negative I. And if you have a remainder of 0, which is just 0.0 whenever you divide, you want to change it just to positive 1. Maybe that'll help you. R1. Huh. Sure.
I think that
Take it one step at a time. Okay, so walk us through what you did for everybody to understand. Multiply all the numbers in front together first, right? So 3 times -2 is -6, times 7 is -42. And then you got 3 i's. What you got, Charlie? Huh? Not yet. And so now it's just, so I to the, what?
It's just 42. Sorry.
It's just, so I got -42 and then I cubed
Or negative 42i.
is -I, and 2 negatives make, what is going on right now?
somehow I made it to 97. I thought I failed it.
Anyway. All right, other questions? Are y'all okay?
But technically, we're going to do -42 times -I, kind of like
I to the third is the same thing as -I. So I replaced it. And then the 2 negatives make a positive. Okay, well, 4 doesn't go into 3, and the remainder would be 3. So I'd replace it with -I.
I got really excited because there's no way I have 97.
All right. Now, I showed you all of this, but then I told you the other day that the whole point in this unit is what? What are we doing? Solving what? Quadratics. So now we're going to take what we know, just like yesterday. We're going to solve the quadratic. These are still going to be SADMAP problems, just like yesterday. The only difference is you're going to end up with negatives under the radical. Okay? SADMAP, yeah. It's a sad cat. Try this one. If you can get this one, I'll stop. Solve it. Yeah, if you can get this one. No problems. And I'll let you do your homework.
I got one question.
Close.
I got one question.
There's just one slight difference. Yeah.
It's a negative. I'm not giving the answer away, but it's a negative. The answer has to be on the outside number or the inside.
It depends on where it comes initially. Tell me what you do first. Tell me what you do first. Plus 3. So I got -4x squared equals 4, 8, 4. Now what? Divide -4. Here's where I'm different from what I was doing yesterday, right? Because now all of a sudden, I have a negative. But because you know what you know now about I, and I do the square root, what is the square root of -121? Keep going.
I got plus or minus.
Plus or minus 11i. There's my two solutions. If you graph this, remember I keep trying to bring us back all together to what we've learned and tie everything together. If we graph this, because my two solutions are imaginary, I'm going to end up in a situation something like this. It never crosses the x-axis because the solutions are imaginary. So as solutions, it just has no real solutions. See why I made you write real on there? Yes. It did not. You will be simplifying today and Monday with what we're doing. You have some on the homework tonight.